Cast your little Jesus spells.
Oh my God, who's this?
Anyway, so
Fire up, Coco. Fire up.
whenever people ask me for like citations, I always give them, but I would like to use one of these responses that Gobers have given me as a response to them and see how they react. So I guess this is the next one I'll try. I don't have one on hand, and I don't jump through lazy loser soups. So that's gonna be my next one.
Cool.
Oh my God, I was just going to say something, but I'm still laughing at the fact of you guys presenting information with actual citations.
Are you the tea lady?
Oh, no, Taylor does have citations, but they don't really say what she thinks they say.
Oh, yeah, they do.
No, they don't. No, they don't. That is why
Give me an example, Coco.
It is so hilarious.
Give me one example.
I'm particularly fond of the example that talks.
Hey, I didn't ask you. Ask Roohif and Coco who actually made the claim.
I'm gonna check anyway. Okay.
First, if they have any answers, and then I'll go to you. Okay.
Okay. No, I'm gonna call you right
do
now.
you have a particular example, Coco? Do you have a particular example? Because you're all white knife.
I do.
But I want to hear you.
You're allowed to speak for me because we all see what you do. So go ahead, Shoebill.
Example.
All right, I've got one, but I'll let Shoebill.
Okay,
you'll let Shoebill. You're the one that made the claim. I want to hear your example.
I'll give you
first.
mine. Yes, I'll give you mine after Shoebill.
Oh, after Shoebill. So he's in a white knife for you right now. Okay, so all the Gobers are so mad at anybody who takes up for another flat earther.
No, go ahead, Rufy.
Example of it happening in the Gobers.
Rufy. I'm out.
All right. So the one that you keep saying, the object's lower, the mountaintop's lower in that paper.
Yeah.
Yeah, right. They don't lower than they are geometrically, right? They lower to a sort of arbitrary starting point during the day. So you keep saying that they, or intimate or imply that objects lower than their geometric position. That's not what the paper says.
Okay, well, they showed that they dropped by pixels consistently throughout the day, so I don't know what you consider that.
Relative to what? Relative to what?
They just measured how many pixels it deviated up and down. Yeah, I guess it didn't have a starting point because they saw it got shorter throughout the day and taller throughout the night.
Right, relative to some arbitrary starting point. Right, but they don't say that they were lower than their geometric position.
I didn't say it did.
It certainly implied it.
Okay, so you're putting words in my mouth and then saying that I'm not. All I did was say the mountains got shorter throughout the day. Is that incorrect?
Shorter than what? Shorter than what?
It doesn't say a reference point. It just says that they changed in pixel height throughout the day. Yeah, they did get shorter throughout the day, so please tell me how my source did not back up what it said.
No, they don't. There's nothing in there that says...
They do. So I was not incorrect in saying that.
There's nothing in there that suggests that they appear lower than where they should be geometrically. Yes, during the day, they will lower relative to where they started. So it's still loomed up above their geometric position.
You'd have to prove it. I didn't make a claim based on their geometric position.
Okay. Then why do you bring up that paper?
Because things literally change in height throughout the day.
Yes. Is that in dispute with anyone?
I was noting, I couldn't help but notice the lack of metrics on how much they're moving. You said pixels. Well, what is a pixel? Is a pixel a square mile or a square centimeter? Come on.
You go tell the people that wrote the paper that. I didn't make the paper.
Well, then why do you bring it up if it has no information?
Because it literally shows the mountain getting shorter throughout the day, according to what? I don't know. According to whatever its geometric position is.
Okay, I'll give you my experience. I'll speak from experience. A handful of arc seconds.
Okay, I don't care.
Yeah, okay, you don't care. A handful of arc seconds at 10 miles, that's like a foot and a half.
So my source still backed up what I said.
Yeah, okay, I'll give you that. That's why midday is preferred when it's at the minimum, because that's when refraction is the lowest.
I disagree with that statement.
Well, you might as well go ahead and disagree with that statement. Yeah, no, hold on.
During the day, the refraction will be the highest.
Yeah, you can go ahead and you can go ahead and disagree with that statement, and that is the point that Roohif brought up. You misinterpret the papers you are bringing forward.
No, the paper literally showed that the mountain changed in height throughout the day. That was my only claim. Did they measure the refractive gradients? Absolutely not.
Right. Okay. But
So go look at a paper that does.
then as I said, as it lowers in the day, that's when refraction is lowest.
So show me a paper that actually measured the refractive gradients that show that.
Well,
We can
I'll
show you
just move on
measurements
to
of
the next
gradients.
paper. I'm just going to move on to the next paper that you brought up.
Measurements of the temperature
I'm just
gradients,
going to
for
bring.
example,
I'm
they have
just
lower
going to. I'm
threshold
just going to.
refraction.
I'm just gonna bring up the
Yes, me a
next paper.
question.
I'm just gonna
Yeah.
bring up the next paper you
Just gonna?
misinterpreted. That is a
I didn't
paper.
misinterpret the last one.
Okay, I won't bring up the next paper. You could just knock yourself out, bitch.
Hey, what's wrong with you, Gay Bill?
Shoebill, do you want to say your thing, and then I'll unmute Taylor.
Yeah, I'm just gonna bring up the next paper that you hung your hat on. That was all about the coefficient of refraction when dealing with lines of sight that are relatively short, several hundred meters, and parallel to the ground. Because in that paper was over and over and over and over again coefficient of refraction. And the coefficient of refraction is the ratio of the refracted line of sight against the radius of the Earth. Throughout the entire paper, it was dependent on the radius of the Earth as the denominator of that fraction. And then you said, oh, but it might be flat. No, because in that paper, every time they mention K equals, they are using the radius of the Earth as the denominator of a fraction. Do you realize that?
I do realize that. However, whenever they were talking about temperature gradients, whenever they invoke temperature gradients from other papers, they say that these temperature gradients would produce a negative K value. That's the only thing I was quoting in that paper. I don't really care what they assume. I want to know what the index of refraction is based on different temperature gradients.
Yeah, and again, the K value is a ratio of the radius of the Earth, which they stated specifically. They defined K as being a ratio against the radius of the Earth, and they gave the radius of the Earth at 3960 miles. So when you're saying, oh, show me papers that do flat, well, you brought up a paper that is dependent and entirely repeated the radius of the Earth time and time again every time they use a K value.
No, but that was looking at whenever they made the claim about the negative K value, they were looking at the temperature gradients. And look, even if they do assume curvature, so what? Okay, let me just say that even if they do, then we would still see bottom-up obstruction in that case.
Now, that's a misinterpretation par excellence.
Yeah, please model that for us, Taylor.
Please model how the normal temperature gradients throughout the day would not cause that. Because this paper, which was actually looking at the vertical temperature gradients, said that they would produce a negative K value.
That didn't mean that doesn't mean bottom up obstruction.
No, you said like a typical gradient would somehow cause bottom up obstruction. Is that right?
Yep.
Please model that. I can't see how that's possible.
Okay. Well, they basically look. I'll get the paper for you. They basically said that normal temperature gradients, which have been measured, by some other paper that was looking at temperature gradients, show that there would be a negative K value. Then they measured things. They did what would it be called? Reciprocal zenith angles near the surface, and found even more curvature. Like it changes throughout the day, and that's even assuming a globe. So imagine if you were assuming a flat Earth, how much curvature that would be, how much drop over distance you would see optically because of that.
All right, two things. I'm actually in this topic in flat Earth versus globe. I'm not a fan of using K values because it kind of pre-assumes that there's a radius, right? So I'd rather talk about just the gradient. Second, a typical temperature gradient will lead to downwardly bending light. I have no conception of how that's possible to even cause bottom-up obstruction. I would love to see that modeled.
Okay, look, I'll give you the exact quote from this paper. And you can knock yourself out.
Roohif?
Yep.
When I said Gay Bill, you said Gay Bill.
What?
You do know that, don't you?
Gabriel?
No, I said Gay Bill.
Gay Bill?
Yeah,
what?
he called Tayler a bitch, and I said, "Oi, Gabriel, behave yourself." And then you said, "Gabriel, go ahead."
I'm pretty sure that's not true.
You
I'm
go
pretty
back
sure
and see
that's
the
not
recording.
true.
It was quite funny,
No,
actually.
yeah, and cause the funny part is it didn't happen.
Hey, Shoebill, what's your problem with women?
The one that wouldn't be quiet while in an exchange in what should have been a
It
doesn't
doesn't matter. It
He never
gives
it
you no
does.
right to talk to women like that. Yeah? If you was in a public space, you'd most probably be talking out of a straw for the next week.
Unless it's a globe woman, because y'all talk to me like that all the time.
Well, I think that's wrong then. Whoever talks to you like that should be held accountable. Yeah?
Do I call you a simp now? Is that how it goes?
I actually am not like Taylor. I don't need white knights and special treatment. Taylor's a little bit
It's
more.
not about white knights, darling. It's about respect, yeah?
Do you give the same respect to everyone or just to the girl Taylor?
I just said about you as well. You just told me,
Yeah,
and I just said, like, well, that's wrong as well, isn't it? So now you're harping on about nothing because I told you my standpoint.
yeah. And I am telling you that you and others have not treated me the same way you're saying Taylor should be treated. So I
I've not
called it
treated you
out.
anyhow. I haven't treated you anyhow, have I? I just said people, regardless of their views, should
Yeah.
not be spoken to, especially women, where men are picking on women because they feel that they can.
You in
That's not
particular
correct.
have been very nasty to me. So yeah, it was you. So when I heard you say
I've
that
never
about
spoken to you before in my life, ever.
yeah, they actually live record this and play it on YouTube. So I can go back if I wanted to. and get
You go back. You go
Yeah.
back.
Can I post a
where
sexist
I've
meme?
never
I want to
spoken
post a
to you
sexist
in my
meme.
life.
Hold on.
Never had a conversation with you in my life.
And how many times did I hear Schlitzy say, "See you next time"?
Yeah, exactly.
Yeah, see you
Can
next
I post a
Tuesday,
sexist
actually.
meme now they're on the topic?
See you next
Now we're on the
Tuesday, and
topic.
you are the epitome of that. Believe me. Unless you consider yourself as a girl, Shoebill.
I
If
will
you're
agree
identifying
that
as a woman, I'll hold my tongue and I'll let you off the hook.
it's hard because there are not many women in the space, and there aren't many sort of men-specific slurs. You know, just actual aimed at men only.
Well, I don't mind. You can call me what you want. I'm not going to cry.
Alrighty. Do.
I'm not going to go down to Woolworths and go and buy all the alcohol and drown my sorrows.
So Taylor, 1/2 degree per meter is enormous. That's not a typical temperature gradient.
I sent you the source. You can go find whatever temperature. They said this is normal temperature gradients, a practical temperature measurement by Hennis 2006. You know, that's just what they measured.
But it's not a typical gradient. Shoebill, what's the typical temperature gradient?
Well, in the paper that she's hanging her hat on, they are confining themselves to the lowest 2 meters above the surface. Once you get away from the ground, and also in the paper that she is hanging her hat on, they talk about once you get 20 meters above the surface of the earth, the temperature of the surface is of little importance. And the temperature gradient is typically between, going through the first few thousand feet, or the first couple hundred meters of atmosphere, you get between 6 and 10 degrees per 1,000 meters.
Yeah, correct.
So we're dealing with, and I find 7.5 degrees per centigrade per kilometer of an elevation change to be a very, very consistent value in my location, in the conditions that I favor, because I don't go out in winter specifically for that reason. I don't do night work specifically for that reason. I have a window of meteorological values that I operate in, and I get extremely consistent results over years.
Can I ask Taylor a math question? Half a degree per
How many near
meter.
the surface? What did you say, Shoebill? What's the temperature gradient that you said?
6 to 10 degrees per kilometer. So your figure here of half a
That's
degree per
30.
meter, what does that equate to
I
per
don't know.
kilometer?
Math equations.
500. 500 degrees.
Near the surface, there is a lot of solar radiation heating the Earth. I acknowledge that.
Yes, right. So get away from the surface. How many times have you heard me say get away from the surface?
How do you do that?
Including that paper that you're hanging your hat on. It says, yes, in geodetic surveys where you're to elevated targets. Yeah, the temperature of the surface isn't at play. Quoting Bomford, quoting all the others in geodetic surveys, elevated targets. Once you get, out of those first 10 or 20 meters and you're going out there for, 20 or 30 kilometers in length and distance, the temperature of the surface of the pavement of which the instrument sits upon is not that important.
But aren't you on the surface?
Oh, hang on. We had this chat the other day. All right, let's say we're on top of a mountain and we're pointing the theodolite 30 miles away to the top of another mountain. Does the 29.9 miles of elevated line of sight overpower the 1/10 of a mile of line of sight close to the surface?
Why would you be using a theodolite to measure 30
It's not a question
miles?
for you, Slithy. It's not a question for you.
I know, but why would you be using a limited tool to do that distance?
I haven't looked at the comparisons of looking along the line of sight versus something off the line of sight, but all I do know is that what you're looking at and where you're at is on the surface or pretty close to it.
Right. And let's say that surface drops away because we're on a mountain looking over a valley.
Yeah. I don't know.
So
You'd
let's
have
say
to
we've got
measure temperature gradients and do the math. Yes.
right. So we've got a 1/10 of a mile at the observer and a 1/10 of a mile at the target. So we've got 29.8 miles through a typical temperature gradient because that line of sight's above the surface. Which one do you think has the biggest impact?
I mean, obviously, the more line of sight you're looking down will have the biggest impact. But then again, whatever you're looking at, wherever you're at, is still going to be affected.
Right. I don't want to have to ask the question again because the answer is obvious. The 29.8 miles.
Unless you have
the
specific
29
math with, I don't know, you want me to play your hypothetical? I already tried. You know what I mean?
Right. The 29.8 miles of looking through a typical gradient because it's above the surface is going to vastly, vastly overpower those 1/10 of a mile.
But whatever you're looking at, it's still going to be affected.
Right? Not by very much.
Okay, where's the math for that?
I can do that for you.
Okay.
I could.
That'd be awesome.
Yeah. It seems a bit trivial, though.
Mm-hmm. I don't think so.
I don't know. Well, yeah. Oh, Bendy Space, the AFIT, that's the hospital one, right? Yep. Yeah, so your paper, Taylor, that you posted, monitoring of the refraction coefficient lower atmosphere, that's up to about 30 meters, I think it is. We all agree, I'm sure Shoebill does agree as well, that, yeah, these observations where your line of sight is entirely close to the surface, yeah, can have big variations.
So you're looking at the Lake Pontchartrain Bridge?
Oh, look, ideally get above the surface, and he's up, was it 15 floors? Something like that?
Well, I took one at 15 floors, and you said I wasn't zoomed in enough.
Yes, zoom in.
I don't have the proper equipment to do that, and whenever you're at the very end there, you can see clear distortion.
Yeah, Again, if there's an inferior mirage, I'm happy for both sides to throw it out.
I mean, even if there's not, you can still have things raising above the surface without miraging, without mirroring or anything like that. And also you can have compression without
Are
miraging.
we talking about? So when I said compression before, I meant simple geometric perspective compression. So like you're looking at a long section at a high focal length. I think you're now referring to refractive compression. Is that right?
Yep.
Okay. Cool. Yeah, I'm happy to discard those as well. Like, no disrespect to B-ball, but one of his observations through an order level has some pretty clear refractive compression, and I'm like, it still shows a substantial amount hidden behind the horizon. But you want like a clean image. Like, I'll grab the cleanest image I have. Give me 1 second.
Do you think clean images can still be a product of refraction?
Say it again.
Do you think just because something's a clean image means it doesn't have any refraction?
Oh, everything has refraction, but not necessarily distortion. So there's like a uniform gradient will not cause distortion. Like an inferior mirage is because you've got the gradient going from upwardly bending to downwardly bending. Compression or towering is all changes in the gradient.
So yeah, you can have clear images that are a product of refraction.
There's always refraction. Every single photo has refraction.
Yes.
Way.
So there you go. That's my favorite photo.
Let me show one of a boat floating in midair.
Yeah, that's not a refraction
long
effect.
distance observations where y'all say it's refracted up, and that's how we can see them. They look like they're in
I'm pretty sure we've had the floating boats conversation at least once.
Yeah, you say that the surface is being refracted down. Is that right?
No.
Oh, it's a mirroring of the sky.
Yes, correct. It's just reflecting off the water.
Yeah.
It's not a refractive effect.
Okay. Yeah. Well.
So, are you going to have another flat Earth reset tomorrow and ask me the same question?
Yeah, I just think that you're just making that claim, But I guess I could just make claims too.
Does the water reflect the clouds? Yes, it does.
In the picture
I can
I'm
go
talking
and get
about?
you. Where's your picture? You haven't posted one. But any of these so-called floating boats, some of the media calls it a Fata Morgana, and they're just wrong.
I was impressed that Jaron had brought that up with Veritasium. He was talking about the floating boat thing, and he pointed out when you zoom in when you look at the photograph and you alter the contrast, you can still see the horizon, and the ship is still in the water, not floating above the water. The horizon is still there. You can still see the water line on the hull. You can still see the prop wash, and then lower in the photograph, you can see a boundary line to where you're going from the glassy water to the ripple water, and the glassy water is reflecting the clouds to where the horizon isn't the very, very low contrast from the horizon to the sky. But Jaron brought that up, pointed it out, because that's well known. Now, the problem I just freak out is that with well-known phenomenon, the flat earthers just go crazy over something that the photograph, disregarding measurement and disregarding and analyzing the photograph to see the horizon and the ship still on the water.
I would love a flat earther to apply whatever refraction ideas they have to the Conti Leon photo I posted at 2 minutes past. How is that possible? What is the path of light?
Dun, dun, dun.
I'm not looking at your picture, so I'm
And
not
just a
looking at
few,
it now.
just, and yesterday someone was carrying on about how those mountain pictures, just destroy the globe. And except they match the globe and they destroy flat Earth because we don't see far enough.
Is that your picture?
Dirth posted Canigoo. Dirth posted Canigoo today. I'm like, what are you
Is that
talking? He
your
says, oh, you
picture?
can see the whole mountain. No, that
Roohif.
is. Yeah?
Is
Yes,
that your
Litty.
picture?
No.
Why are you posting pictures of what are not yours, asking people to comment on them?
Yeah, I'm not going to entertain that bullshit, Litty.
Okay.
Yeah.
When you post your own pictures, then we can have a look at
Right.
them. Yeah.
Cool. Okay.
Okay. I'll put notification on, waiting for that.
Yep.
Okay.
Should I put a note against your name? Cannot use any evidence unless it's your own.
No, let's put a note. Let's go
Just in
down
case.
to Warwell.
Yes,
Let's go down to
please add
Warwell.
that note. Please add that note because that'll be funny.
Yep.
Let's go down to Woolworths and get drunk.
Woolies.
At least you're not so drunk on this platform.
What in the world is it with you and getting drunk at Woolworths, please?
Ask Rohypnol.
Maybe.
No,
I
no,
hardly drink.
You're the one that keeps bringing it up. So I want to know, like, is that normal for you to go to Woolworths and get drunk?
Yes.
Woolworths don't technically sell alcohol. There is.
They stopped.
what's it called?
They stopped selling alcohol.
No, they've got like an offshoot. The name escapes me, but they're sister companies.
The concession within inside Woolworths where you can buy alcohol. Yeah.
I can see the face.
Is that what you like to do, Schlitzy? Because your name, I have to tell you, your name makes me laugh all the time. And I know I've said this before, but Schlitz is like a really cheap, nasty beer here in the United States. So honestly, I think of you drinking cheap alcohol every time I see your name.
You got a problem with that? Because that's my great-grandfather.
Do I have a problem with what? Cheap, nasty American beer? Yeah, everyone should have a problem with that.
You used to suck that down your face.
Yeah, I'm asking if you can have superior mirages in proportion.
Dan Murphy's is the Woolworths alcohol shop.
So can things be refracted up in perfect proportion? If this whole boat thing is just like
Yes, but
a mirroring?
if you're close to that sort of stuff can only happen close to the surface. And if you're close to the surface with light bending upwards, you will necessarily have a inferior mirage.
No, a superior mirage.
Not with
I'm asking
bending
about,
upwards light.
I'm
No.
asking about superior mirages.
No. There's no inferior. There's no upwardly bending light there. You can get Fata Morganas. You get an inverted image with extreme downwardly bending light as a superior mirage.
Yeah, I'm asking if you can have superior mirages in perfect proportion. If this boat phenomena is just
What do you mean perfect proportion? It's a mirage. Like it's inverted.
no
saying
inversion,
perfect
no
proportion.
mirroring, nothing.
Then
Can
it's
you
not
have
a
an
superior
object?
mirage?
Okay, so then what would you call it if an object's just appearing higher in perfect proportion?
Yeah, just looming.
Okay, so looming is real, but the boat thing is not looming. Is that what you're saying?
What? Look at the two photos I
I'll be
posted.
very careful.
Wait, I was asking Roohif a question.
Yeah, I'll be very careful. Looming is the typical state in basically every photo. This effect that you're seeing in these floating boats photos is not a refraction effect. Nothing to do with refraction, even though both boats are probably loomed up because that's the typical state. Were they clear enough?
And in that image, the boat is not separated from the water.
I have a question. So the sky is reflecting. Why does it only choose to reflect that distance? Why isn't the whole
Yeah,
the
could be
whole water being
clouds.
reflected?
It's a wind
Right,
pattern.
clouds
It's
or the wind,
There's
yeah.
there's a wind pattern near shore, which has the ripple of water, and then there's the glassy water further out. And so it's just this is the classic optical illusion because when you look at it, carefully, you still see the horizon, you still see the ship floating on the water, and you see a boundary between the ripply water, which would be a shore, you know, an onshore breeze, and the glassy water. It happens. It's been documented in
Yeah.
photography. And if
No, I
you
agree,
and
it
if you
happens.
take that photo, and if you take those photos, you know, and move the curves, you can make it look like the ship is separated from the water.
I
But
got
it's
you.
not.
That's perfect. So, Roohif, you think that objects can appear higher than normal in perfect proportion,
Yeah,
but they
that's
they
the
appear
typical
lower than
state.
normal in perfect proportion?
Well, that's I kind of already said that. If you are if you have upwardly bending light, that only happens near the surface, right? And if you have upwardly bending light close to the surface, you'll necessarily have an inferior mirage. So the
Answer's yes.
upright image, might be perfectly in proportion, but you'll have an inverted image below it.
Oh, so you have to have mirroring. You can't just have a perfectly downward refracted object.
No. Like, what is the path of light? If you've got upwardly bending light, what is the path of light? With an inferior mirage, you've necessarily got like a hidden zone. I have to draw this. Should I draw it?
Glassy water.
Let me share. Oh, it's 12 past 8. I've got to feed dogs. Can I draw this tomorrow? I'll go and feed dogs.
Oh, draw it now.
No, it's after 8 o'clock.
Come on.
Area. I'm just checking whether I've got it already. I don't think I got it. No, I don't. But
Area?
I don't have a slide that I've already done. But yeah, I'll write it down. Do it tomorrow.
Is there a program where we can actually see the effects if we input the parameters?
Yes, Mick West. In fact, I'll give you that. That'll be good. That'll save me doing that. Mick West refraction. 1 sec. Boom. Copy. Oops. In the chat. There you go. You experiment with inferior mirages. So you need to put the temperature close to the surface, quite warm, and steeply changing. And you'll
Is
see
there
the
one
inferior
for
mirage.
the plane instead of just a globe automatically?
Say again.
Is there one that doesn't have a globe automatically input?
Oh yeah, tick the flat Earth button. Yeah,
Wait, there's a flat Earth button?
yeah, it's a simulator.
This is perfect.
Yeah.
Hopefully it's based on real observable math.
Sure.
Okay.
Anyway, I'm out. I'll catch you guys. See you 6.
Bye, Roohif.